Find the sum to n terms of the following series. Let us begin. So here we have a series where the first term is 5, followed by 7. Then we have 13. Next term is 31. And then we have 85. Now this is a series and we need to find its sum to the n terms. However, this series is not an arithmetic series, neither it's a geometric series because it does not have any common difference, nor does it have any common ratio. However, if we consider the second term and subtract the first term from it, we're going to get 2. Take the third term and subtract the second term from it, that's going to give us 6. Next, we take 31 and from here subtract 13, so that's going to give us 18. Then we have 85 minus 31. So that's going to be 54. So here we can observe that the terms 2, 6, 18, 54 and so on, clearly these terms are in geometric progression. They are in geometric progression with the common ratio of equals to 3. Now what we will do, we can use this information to find out the sum up to n terms. To begin with, let us suppose that let Sn represents the sum up to the nth term. So here we're going to consider the last term of the series and denote it with Tn. And then we are also going to consider the second last term, which is denoted by Tn minus 1. Next, what we'll do, we'll consider the same sum Sn. So we have 5 plus 7 plus 13 plus 31 all the way up to, we have Tn minus 1 plus Tn. Fine. We're going to subtract the two series. Sn minus Sn, so that's going to be equals to 0. Then our first term, that's going to be 5. Added to 7 minus 5, we've already obtained. This is going to be 2. 13 minus 7, that's 6. 31 minus 13, that's 18. 85 minus 31, that's 54. Then we go on to the second last term. So that will be Tn minus 1. And then we have the last term, which is negative Tn. Now we'll be transposing this negative Tn to the left hand side. That's going to give us Tn. Let's keep the first term as it is. Now from the second term onwards, all the way up to the second last term. So this is a geometric series with the first term being 2, common difference being 3, and the number of terms being n minus 1. So there are n minus 1 number of terms. Now let's verify why it's the case that it has only n minus 1 number of terms and not n number of terms. Now for the first sum Sn, we excluded the first term, which is 5, and we considered the second term all the way up to the last term. So by definition, Sn has got n number of terms. If we exclude one of the terms, so it's going to be left with n minus 1 number of terms. Then for the second sum Sn, we consider the first term all the way up to the second last term. We excluded here the last term, which means this one is also going to have n minus 1 number of terms. Now, after subtraction of n minus 1 terms from another n minus 1 terms, we'll be left with n minus 1 terms. Fine. And now, since this is a geometric series, we know the standard sum to find out the sum to n terms of a geometric series, that's given by the first term multiplied to r raised to the power of n minus 1 divided by r minus 1. And this is the formula when the magnitude of r, or can say absolute value of r, is greater than 1. In our case, we have the common ratio r equals to 3. So that's going to be greater than 1. And we have the first term a equals to 2. Let's use this sum. We have 2 times 3 raised to the power of the total number of terms, because here n represents the total number of terms, but in our case we have n minus 1 terms. So we raise 3 to the power of n minus 1. Minus 1 divided by 3 minus 1, which means Tn comes out to be equals to 5 added to 2 times 3 raised to the power of n minus 1 whole divided by 2. So here we can factor out 2 from the numerator and the denominator. So we have Tn equals to 5 added to 3 raised to the power of n minus 1 minus 1. So Tn comes out to be equals to 4 added to 3 raised to the power of n minus 1. So now we have obtained the nth term of the series. Our next task will be to find out the sum. So that's will be simply defined as, to find out Sn, we'll take the summation of the nth term, but what we'll do, we'll replace the index n with k. So k here goes from 1 to n, which means that we need to find out the summation of 4 added to 3 raised to the power of n minus 1. with the this is going to be the index k, where k runs from 1 to n. So we get summation of 4 with k going from 1 to n, added to summation 3 raised to the power of k minus 1 with k going from 1 to n. So here the first summation is simply 4 plus 4 plus 4. So we have 4 getting added to itself to n number of terms. And then the second summation is a geometric series, with the first term being 3 raised to the power of, so we have to use k equals to 1 for the first term, so that gives us 3 raised to the power of 0. Second term comes 3 raised to the power of 1, third term comes 3 squared, and it goes all the way up to 3 raised to the power of n minus 1. So here we have 4 getting added to itself n number of terms, so that's 4 times n added to. Now we have again a geometric series, so its first term, that's simply 1 will get added to, multiplied to the common ratio, which is 3 raised to the power of total number of terms. Now here the total number of terms, it's n, it's not n minus 1, because we have specified in our summation that k runs from 1 to n, which means that there are n number of terms and not n minus 1. So we have 3 raised to the power of n minus 1 divided by 3 minus 1. This is going to now give us 4n added to 3 raised to the power of n minus 1 divided by 2. Combining them, we get a common denominator 2, where we have 8n plus 3 raised to the power of n minus 1, and this is going to be the sum up to the n terms of the given series.